Okay, in this question, I'm given a volume, a temperature, a whole bunch of grams, and I want to start by finding a pressure. Pressure, volume, temperature, and grams, which I know I can turn into moles, gives me the clue that I should be using PV equals nRT. Different ways of solving this, but how I'm going to go about it is looking for my total pressure. If I want that to be my total pressure, then I need that to be my total moles. I'm going to find moles of all the gases and add them up. Then I can plug in and find total pressure. So of my different gases, 15 grams of argon. For argon, grams equals moles times the molecular weight of argon, which is 40. Six grams of neon, grams equals moles times the molecular weight of neon. Hydrogen, be careful, remember that hydrogen is a diatomic. So when I say hydrogen, I really mean H2. Grams equals moles times the molecular weight of H2. And fluorine, also a diatomic, so F2. Grams equals moles times 38. Our moles is 0.263. Getting my total moles, so I can plug total moles in, means adding all of these up. So 0.263 plus 1.5 plus 0.3 plus 0.375. My total moles is 2.44. PV equals nRT, solving for P. They gave me volume, but make sure you put it in liters. Using my total moles, R is always 0.0821, and temperature is 20 Celsius, but I have to turn that into Kelvin. So I think I need something wrong. 2.44 times 0.0821 times 293 divided by 0.6. I didn't get something wrong, it's just a weird question. I get 97.8 ATM. That's my total pressure, again, because I used my total moles. Now for part B, finding the partial pressure of argon, I have different choices for how I want to solve it. Just like when I plugged in total moles, I got total pressure. If I want to find the partial pressure of argon, I can use PV equals nRT, plugging in the moles of just argon. That's one option. So if you do that, it would look like this. Still the same volume, but the moles we'll use is just argon. Still the same temperature. 293. Solving that, you would get your answer, which is 15 about. Or you can find the mole fraction of argon, basically the percentage of the total moles that is argon, and take that percentage of the total pressure. So 0.375 moles of argon out of the 2.44 total moles, that's telling me my percent argon. It's giving it to me as a decimal, but it's telling me the percentage. So 0.153, 15%. 15% of my total pressure is because of the argon. So you can take that times 97.8, and you would still get the same answer. You'd get about 15. Either way works.